Welcome to this explainer. Have you ever stopped to think about what actually happens when you tap your screen? I mean, every single digital action you take, whether you're streaming a movie, firing off a quick text, or buying something online, relies on this totally invisible, highly structured infrastructure. It's basically a vast digital highway system working flawlessly right behind the scenes. And today, we're going to decode exactly how the whole shebang works. So here's our roadmap for today. We're going to start with the invisible digital world, zoom out from PAN to CAN, and then go global with MAN and WAN. After that, we'll hit the hardware highway, dive into cloud, edge, and security, and finally wrap things up with the business of networking. All right, Section 1, the invisible digital world, the hidden backbone of modern life. Let's establish a foundational truth right off the bat. Computer networks are the absolute bedrock of modern society. I really want you to think about this for a second. Do you know exactly how the explainer you're watching right now actually reached your screen? It definitely didn't just appear by magic. Your video was broken down into these tiny packets of data, fired across the globe at literally near the speed of light, routed through insanely complex intersections, and then reassembled right there on your device, all in just milliseconds. Crazy, right? And hey, it's not just streaming. Literally every digital interaction depends on these networks. From shooting off instant messages and emails to making secure online payments. Whether you're accessing cloud services or just endlessly scrolling through social media, you're using the exact same foundational networking concepts. The only real difference? The scale. Moving on to Section 2, zooming out. PAN to CAN, scaling from your body all the way to your campus. We're going to build our understanding from the smallest personal networks up to much larger organizational ones. Okay, so the absolute smallest network is the PAN, or Personal Area Network. Think of this as your own private digital bubble, usually covering just 1 to 10 meters. In the real world, when you connect your wireless earbuds to your phone via Bluetooth, or when your smartwatch syncs up, boom, you've just created a PAN. And you know, this is becoming even more crucial as 5G and IoT devices constantly surround us. Now, zooming out from just you, we reach the LAN, the Local Area Network. This covers a whole room or maybe a building. In this kind of setup, workstations, a printer, and a file server all connect into a central device. That's called a switch. It allows everything to share resources with basically zero delay. Oh, and by the way, if you're using home Wi-Fi right now to watch this, you're using a WLAN, a wireless local area network. Let's zoom out even further to the CAN, the Campus Area Network. If you take several LANs from different buildings, say the science lab, the library, and the dorms at a university, and you link them all together, you get a CAN. It allows an entire academic institution or a massive corporate headquarters to act as one cohesive network. But stick around, because later we're going to see how data travels way beyond a single campus. All right, Section 3, going global. MAN and WAN, bridging cities and continents. Here is where networking steps outside your local environment and becomes a truly massive interconnected web. There's a pretty stark contrast between these next two scales. First, you have a MAN, a metropolitan area network. This bridges entire cities, connecting things like government buildings or smart city infrastructure. But then you look at a WAN, a wide area network, and, well, a WAN doesn't care about city limits at all. It connects completely different networks across provinces, countries, and yep, even entire continents. Which leads us to a pretty massive realization. The internet itself is absolutely the largest wide area network in existence. At this unbelievable scale, it's actually often called a GAN, a global area network. It is the sprawling web built on satellite communications and ridiculously fast backbone infrastructure provided by internet service providers. Next up, Section 4, the hardware highway, directing the flow of global data. So, how does your data actually navigate this massive web without getting completely lost? Let's talk hardware. So, people mix up routers and switches all the time, but their jobs are totally different. Think of a router as a highly caffeinated traffic controller at a major highway intersection. It looks at destination IP addresses and forwards data between completely different networks. A switch, on the other hand, is more like an office receptionist. It operates within one single local network, just handing out traffic to the specific computers plugged directly into it. So, how does data actually find you? Well, when you type a web address, you use words, mostly because we humans are pretty terrible at remembering long strings of numbers. Computers, though, they only speak numbers. Enter DNS, the Domain Name System. It acts as the internet's giant phone book, instantly translating that web name into an IP address. Armed with that exact location, routers use what's called packet switching to forward your data hop by hop along the absolute fastest path. And the physical roads for all this traveling data? Believe it or not, they're mostly made of glass. Optical fibers, which are roughly the width of a human hair, form the high-speed backbone of the internet. By carrying incredibly fast pulses of light, they transmit data at trillions of bits per second. And because they use light, they suffer almost zero signal loss and are completely immune to electrical interference. These are the actual physical cables laid deep underneath our oceans, literally tying our continents together. It's wild to think about. Moving right along to Section 5, Cloud, Edge, and Security, protecting the digital nervous system. Because, with great global connectivity comes great vulnerability. Okay, let's clear up a major misconception right now. A virtual private network, or VPN, is not some magical invisibility cloak. It's actually just a highly secure, encrypted tunnel routed directly through a public network. It allows remote workers to connect to their company's private network safely, ensuring their data stays completely scrambled and unreadable to anyone trying to snoop on, say, the local coffee shop's public Wi-Fi. Of course, modern networks also rely on a heavy arsenal of infrastructure. You've got firewalls standing as guards at the gate, deeply inspecting electronic access. Meanwhile, CDNs use geographically dispersed edge servers to cache data right in your backyard, completely killing lag and latency. And as we scale up to massive cloud computing and AI infrastructure, load balancers step in to distribute millions of requests smoothly across colossal data centers, so the servers don't just crash under the weight of it all. And finally, Section 6, the business of networking, careers in the digital economy. Because understanding all this isn't just a fun academic exercise, it is a highly lucrative opportunity. Every single thing we've talked about today requires human expertise to keep it running. Understanding this invisible infrastructure opens up some massive monetization paths. We're talking network engineering, cybersecurity consulting, building cloud businesses, or even freelancing once you've got the right networking certifications. There are even entire niches for tech content creation just explaining these systems. The entire modern digital economy fundamentally rests on this connectivity. Which brings us to our final thought. Computer networks are the invisible infrastructure behind modern civilization. The next time you send a text or stream a video, try to visualize that incredible journey. From your personal bubble through local switches, fired as pulses of light across the bottom of the ocean and delivered perfectly to your screen in mere milliseconds. You are constantly connected to this massive global machine. So the question is, will you just be a user of it, or will you learn how to build and protect it? Thanks for joining me on this explainer, and keep learning.